It all starts with one idea. Have you ever wondered how today's top CEOs, business leaders, and people who work for the most innovative companies in the world found success? Join host George Davison as he explores the innovators that are shaping tomorrow's world today.
Today we have David Meyouhas, and he is the Senior Director of Standard Products Space Division for the CAES organization.
Thanks for having me, George.
Thanks for taking your time today. David, I have a lot of questions I'd like to run by you today. You have such an interesting career and interesting organization that you're with. Maybe we could walk it back and let's take a look at how did it all start? Can you take us through that a little bit?
Absolutely. Great question, George. Really, it all started with Sir Alan Cobham in the 1930s, where he developed refueling systems for common aircrafts. And from there, various companies started piecing together to make up what is known today as CAES. We have about a dozen different sites, mainly located in the United States, but some in Sweden and one in Mexico as well. But the site that I hail from, as a function of the Space Systems Division located in Colorado Springs, we really had individuals that still work there today that actually laid brick by brick the building that houses the manufacturing site today. That the engineering team that is there designing day in and day out those semiconductors that have to go up into space. That's really, blows my mind really every day, where we talk about, closer to Earth, starting off with airplanes, and then going all the way up into outer space, into deep space, into going all the way to Mars. It's just mind-boggling, really.
It really is. So our audience out there, let's make sure they know how to spell CAES, because they may want to do a little research after listening to your story today. Can you spell it out for us and explain what it means, please?
Absolutely. CAES, it's a function of Cobham Advanced Electronic Solutions. So really, it's all about advancing microelectronics, pioneering advanced electronics to really mission match whatever missions our customers require today, whether it's land, air, sea, or out in space.
That's wonderful. Can you tell us a little bit about yourself? I mean, how did you get to where you are? Maybe that would help our audience to understand that you weren't always an executive at this organization. You started out as a young buck somewhere and worked your way up, didn't you?
I sure did. Good point. Yeah, my background stems from mechanical engineering. So I've got my undergrad in that, and shortly after I received my degree, I started working at Pratt & Whitney, which is a airplane engine manufacturer. And so that's really how I propelled with proximity to engineering, all the technical. I wanted to know how an engine worked and how we actually got planes up into the sky.
Interesting.
And so started off with that, worked across various disciplines within that company, whether it was continuous improvement, quality, supply chain, and really as I looked at that opportunity, I said, there's got to be a way to go higher than where airplanes go. And where do you go from there? You go to space. So that's what landed me really here at CAES, and it's been a great experience. It's an opportunity for me to really speak to customers to understand what challenges or what problems they're trying to solve with next generation spacecrafts or next generation satellites, and how we can help design products that solve those problems.
Interesting. So part of the process is going to be talking with customers and listening to their needs, right? Or maybe utilizing an observational analysis of what some of the challenges may be. And then do you develop the ideas and start to formulate solutions for them? Is that what you're talking about here?
Absolutely. So we start off with concepts or roadmaps where we see, hey, here's what we currently have as a concept product for any given product family. And as we share that with customers, we start to collect feedback. And, it'd be nice to have this feature on that product, or it'd be nice for that product to operate at this temperature. And so as you start collecting those various data points from multiple customers, multiple missions, it starts to form a better picture of what that product needs to be.
That makes sense. So that need is is what we call an opportunity, right?
Absolutely.
And so now you go about trying to figure out a solution and how it would be made and marketed to that market so that the business can operate and sustain itself. Is that a fair way of saying it?
Exactly. So the key there is getting all these data points, having all these requirements from various customers. How do you consolidate that into, because you can't thread all the needles. So it's important to really understand or start to determine when you cluster the data points, you start seeing a picture of, okay, this is really what's important, and this will address 90% of the market or 90% of the audience.
Interesting. So from what I understand, you have some children in your lives, and you mentor them in some ways. Could we talk a little bit about how you mentor and also touch on, if you would please, if somebody helped you along the way when you were younger that mentored you that might be helpful for our audience?
Yeah, wow, there's a lot to unpack there, George. So let me start at the beginning. I've got two beautiful, smart daughters. Emphasis on smart, Lily and Naomi, and very, very inquisitive, very curious. And so whenever something breaks down at home, which, as you know, is often, my de facto engineering pride is to try to fix the problem myself. And they're right there alongside, under the sink, or pulling apart the dishwasher and handing me tools. And maybe they hand me a flathead when I ask for a Phillips, but that's okay. That's how they learn. And so it's really important for me to share that with them, and for them to get a passion for trying to fix things, and understanding that it's okay for them not to have the answer or to fail, because you take that experience and you grow from there.
Yes. Build confidence off failure.
Absolutely.
That's been said before, right?
And your follow-on question was, how did you grow up, and did you have a mentor? And it's probably a little cliche, and I'm sure you hear it all the time, but really my father was my mentor. I'll give you a prime example. He had his own business, so he was an entrepreneur, and he repaired TVs and VCRs. For the audience, a VCR is what existed before Netflix. It was very cumbersome. But in any case, my father was and still is a genius, and just a subject matter expert in his field. I'll give you a prime example. When a certain company released a television, a few months later, they started seeing a significant amount of TVs start failing. So basically, it wouldn't turn on after a few months, which was a problem when you shipped millions of TVs to consumers. And the engineers at that company were just unable to solve that problem. My dad just pulled apart the TV. Within a couple of hours, he called them up. He said, this was the problem, and this is how you fix it.
That's wonderful.
Yeah.
Yeah, that's hands-on, real-world knowledge.
Absolutely.
You were very lucky to have a father like that who can inspire you. So I want to thank you for being here today, because I'm hoping you can inspire some other youth that are out there listening to this. Would you have any suggestions? Let's say that Dad's not home very much, or Dad isn't around. Maybe I don't have a dad. Suggestions on how to get some experience, maybe as a youth, to some maker time. Do you have any ideas there?
Right. For me, the experience at school, having after-school projects or joining clubs, in high school or college, when you have various teams that are there to develop solar panel cars for racing, or wind power cars, being exposed to those types of opportunities, having mentors within that environment who have been in the industry, know what it needs, or understand that failure is acceptable, because you learn from that, and then the next iteration will be even better than had you succeeded the first time around.
Right. Yeah. Oh, that's a great suggestion. So clubs and things where you're going to get your hands dirty a little, and hopefully somebody's helping you shoot for the stars to make something, right?
Absolutely.
That's good. All right, so let's chat a little more about STEM-based classes, STEM, science, technology, engineering, math, or STEAM, science, technology, engineering, art, and math. Do you foresee that as being an important part of your daughters coming up? I mean, how important is STEAM and STEM to them, do you think?
Today, they're coming up in that path. I continuously try to reinforce to them, hey, which engineering discipline are you going to go to college in, or which technical degree do you want to get? Right now, my eldest daughter wants to be a mermaid engineer, so I'm not quite sure that's a valid, but we'll get her there. Really, I want them to be passionate about it, right? I want them to grow up and enjoy what they do, but there is just so much tremendous opportunity in the realm of STEM, in the realm of engineering, any type of technical discipline. There's just huge growth in that market, and really, as you come up through school, as you go through internships and really get a taste of the real world, it teaches you how to solve problems. And if there's one thing that job security has taught me, is that there will always be problems to solve. And as long as you're equipped and you have the right approach to solve those problems, you're gonna do great.
Well, that's really good advice. So problem solving and companies go hand in hand.
All day.
That's good stuff. All right, so let's see here. So knowing what you know today, what advice would you give a person interested in entering into your industry?
Knowing what I know today, had you told me 20 years ago I'd be working hand in hand with customers getting spacecrafts to different planets up in space, I wouldn't believe you. And I think if you go back to the school days, I would say don't restrict yourself to diving too deep into one specific discipline. Try to go at it from a broad approach, because you don't really know what you might fall in love with or what might be useful down the line.
So that, just following up on that, so if you're out into lots of different subjects that you're exploring, and you happen to find one that you have a lot of interest in, then maybe you have a lot of like to that. So it doesn't become schoolwork anymore, does it? It's more like it's a passion, and I love to do it. So I do it in my off hours because it's what I like.
There you go. When you find that one thing that really doesn't feel like work, dive in.
I love it. That's great stuff. All right. Well, hey, the youth, all of you out there listening today, that is some great advice. Explore many different subjects. That's why when you're in school, you get to explore around and try different things. And don't worry about failing. It's okay. But hopefully you're going to find what you like, and then you'll become passionate about it, like you have, David.
Well said, George.
So, all right. So let's move on to the next question for you. Do you believe anybody can be successful out there? And if so, what would you say is one of the most basic building blocks in order to be successful?
The most basic building block to be successful is the willingness to fail. Not be afraid of failure. Embrace it and use it as a springboard for success on your next try. Do I believe anybody can be successful? Absolutely. The key to that is they have to be willing to put in the work to become successful, because you can't hit the easy button on that. You got to put in the work.
There you go. So I guess that gets us back to a previous question, which was, if you find what you like, you're going to put in the time or get the work done, aren't you?
Absolutely. But the great thing about it is, if you love what you do, it really won't feel like you're putting that much time into it. It'll just be organic.
Isn't that nice?
Yeah.
That's a good life, right? So you get to work in something that you're passionate about. We have our own personal selves, our family, and our work in our lives for the most part. And enjoying as much of that as we can, I think, is a good life. So thank you for that.
You're welcome.
All right. So, would you happen to have a maker tip? Anything that you think would be helpful to the kids out there taking STEM and STEAM and, or innovation courses, things of that nature? Do you have any maker tip for our students today?
Yeah. Regardless of which situation you're in, if you're in the classroom or you're just starting off at work, and there's an opportunity that presents itself. Let's say you're in a room, the teacher asks, hey, can anyone help with X, Y, and Z? I've seen a lot of instances where there's just deathly silence across the room. Nobody wants to raise their hand. Everyone's afraid or timid. My maker tip is raise your hand, volunteer. Whether or not you feel like you're equipped to pull it off, it doesn't matter. You'll figure it out.
That's great advice. Great advice. I am so glad that we covered that question, because that silence in class where no one's putting their hand up it's tough on the teacher too, I think.
I would agree. Yeah.
All right. So get out there, right? Put your hand up and explore that area. Great advice. All right. So let's touch back into your industry a little bit. And if you're looking into the future, what do you think the next big innovation will be in that industry?
That's a great question. When we look at space today, you're seeing what's called a new space, or space 2.0, and that's where the SpaceXs of the world, Blue Origins, they operate. And really, what they're trying to do is commercialize space for everybody, and that really has been enabled by a lot of the advancements in technologies and electronics that. Lower cost components are able to now satisfy those types of missions, and so it's a function of ensuring that as the performance of those products continue to accelerate, we need to ensure that they're able to survive those harsh environments out in space.
All right, so innovation in materials that can sustain time and space. Is that fair to say?
That is very fair to say, yes.
All right. So if I'm in high school or middle school right now and I heard that, I think I'd ask, well, how could I prepare myself to be in that space one day?
Right. Again, I think you hit the nail on the head at the onset of this discussion, where STEM and STEAM are just critical. That is table stakes to get in the front door. And once you're in the front door, sky's the limit. The great thing about our industry, as you look at the growing need for products to be trusted, for electronics to be trusted and onshore, there's a lot of concern, there's a lot of risk with some of these semiconductor parts that are out there. And we're just seeing a huge trend of onshoring, of bringing products and manufacturing back to the United States, and that's definitely a different story than what we've heard over the past 30 years. So huge opportunity for growth, huge opportunity for jobs right here in the United States.
All right, so for our viewers, onshoring is when we are bringing manufacturing and jobs back from overseas operations that in many cases we set up, and we're bringing them back to the United States so that we can better control quality control and other security matters, so that when we do go to space, we believe that we have the type of reliability that we need in order to perform well up there. Is that okay?
Absolutely, in a trusted, assured environment.
Great. All right, so talking about CAES, and you brought some goodies with you today that are laying out on the table. And if we could describe some of these as to what we're looking at, I think it would be helpful for them to, get a little talk about this stuff.
Absolutely. So it's a little bit hard to describe over a podcast, but I'll make best efforts. Really, when you look at semiconductors, you have dye that are packaged in a ceramic container, and that is there because it has been proven to survive the rigors of space. And so what I have here with me is actually the first radiation-hardened microcontroller that CAES developed and put up in space on a NASA mission in the early 90s. And the great thing about that mission was that it was initially only designed to survive 3 years, and they actually only decommissioned it after 20.
Wow.
So really testament to the entire engineering on and around that satellite, that it could outlast what it was initially intended to.
That's wonderful. So it's going to be radiation hardened for what reason?
Right. So semiconductors that are not standard semiconductors that are exposed to radiation, such as particles that are emitted in our solar system by the sun, that'll fry the circuit. It'll cause it to latch up or stop functioning. So if you took your phone to outer space, within a matter of weeks or months, it would stop working. So what our claim to fame is really our engineers go inside the DNA of that circuit, modify it such that it can withstand getting bombarded by radiation out in space.
That's wonderful. Well, that sounds like it's a whole world to explore all in and of itself. So
absolutely.
All right, so that's the first one we're looking at. What's the second one, David?
So the second one, it's one of our Leon microprocessors, which was a joint development between Colorado Springs and Gothenburg, Sweden. And that component is actually on the Martian surface today on the Mars Perseverance rover.
That's fabulous.
Yeah, and so it's helping doing some laboratory experiments on the Martian surface to understand how do we convert CO2 into oxygen, and obviously the end game there being, okay, if we want humans to ever live on Mars, we got to figure out how to make oxygen.
Right.
So we're really enabling those types of advancements, and it's fun to talk both to the audience and to my girls back home.
That is so exciting. Well, there you have it. That's a big future out there. Some good stuff to chase. We have a couple more. You want to touch on those too?
Yeah, absolutely. Moving on to the right, we have one of our newer microcontrollers, which is, as you compare to the first one that was developed in the early 90s, it's just a lot smaller. For the audience that can't really see it, but it's much, much smaller and actually has much more computing capability than the one we developed back in the 90s. So that's a common theme in semiconductors. You go from 1,000 transistors to today billions of transistors, and those transistors are able to turn on and off independently, and that helps enable computing. So even when you think about your phone, when you open up an app, that you need a microprocessor in the back doing all that processing, all that thinking. So we've really been able to shrink down that capability and even increase that capability over time.
Yeah, there's a lot of value into trying to get these as small as possible, yet still very powerful. Right?
Absolutely. Yep. Size, weight, all that is extremely important for these missions.
Yes. It's expensive to lift things into space, isn't it?
It is expensive, and you have to make sure it's low power because you're running off batteries and solar panels, and you only have so much power to harness.
Right. So a lot of challenges to figure out there, and many more coming. All right, so what's our fourth one, David?
The fourth one is really, as you look into the future, this is what's called a chiplet. And really, as you look at the products that I brought and spoke about earlier, those really have a single chip, a single piece of silicon or wafer or semiconductor. And as we progress the technologies for that product, we realize that with the increase in performance, it becomes harder and harder to produce. And so to break that paradigm, going from one chip that's kind of the end-all, be-all, you try to jam everything into it, really now chiplets break it up. So think about it from a puzzle, and each chiplet has its own piece of the puzzle, and you can choose the technology that's best suited for that individual chiplet. and really just have a tremendous gain in performance and capabilities by stitching all the different puzzle pieces together.
That's a great way to think about that. So if I'm a student and I wanted to tinker around with some of the types of things you're talking about today, are there any products that you could that I might be able to reverse engineer or to take apart? And, what would you suggest about how to get a little closer to this if I'm in high school or middle school?
Yeah, that's a great question. Really, today, you can't open any piece of electronic without finding semiconductors in it. And so if you have an old PlayStation that doesn't work or an old TV that doesn't work, and you want to, with your parents' approval, tear it apart and start to tinker with it, kind of see the bits and pieces on the inside, see how everything works. And that's a great opportunity. And really, I took apart a great many things when I was young, and I didn't always ask permission, so I maybe got into a bit of trouble there. So make sure, kids, you ask permission.
Right, and it's not plugged in.
Exactly, yeah. You break apart the microwave. Mom and dad won't be too happy. But yeah, just have an opportunity to really delve deep, touch things, right? Open things apart. Don't just Google it. Don't just read a book. Those are important foundational elements, but really to touch something and to understand how it works is a tremendous value.
Super. All right, so we're at CAES, and here we are all these years later, and let's talk to the audience a little bit about how many people are employed by the organization and the difficulty you may have or may not be having about hiring people with the right skills today.
Yeah, that's a great question. For our site and or our space systems division under CAES, we have about 500 employees. And from a STEM standpoint, it is very, very challenging and very difficult to attract and hire the right talent because it's so in demand right now, and we don't foresee that demand diminishing anytime soon. So we're really competing with a multitude of companies that are after that exact same skill set. And so it's important to really give an opportunity for those individuals to really expand the innovation in microelectronics and give them an opportunity to really push the boundaries, think outside the box, bring us to the next level. And that's really important. And you need to have that engineering, you need to have that STEM, that math understanding to bring to the table, because as I stated before, that's just table stakes. You got to have it.
And it sounds like there's more demand than there are students. So this is growing rapidly, and we need students in this space.
Absolutely. You really cannot go wrong, and that's why I'm pushing my daughters in that direction, hoping that they will fall in love with that discipline and really help the mission, help these various companies, help CAES in the future, really develop innovative products to solve really tough problems out there. How do you take a sample from the Martian surface, shoot it up, and then have another spacecraft catch it mid-flight and bring it back to Earth? Right? These are not easy problems to solve.
Mm-hmm. That's a great. Boy, isn't it fun to be able to look at problems and challenge yourself to try and figure out the best way to bring a solution to that. For me, anyway, that's a great life, and I love solving problems. So hopefully we can get more of our youth. There's a lot of opportunity out there, and hopefully they're listening pretty closely right now, so we can help, right? If we were to speak directly to the education leaders of today, let's say for a moment, what would you recommend to education leaders that the best way to try and prepare our youth for the jobs of the future? Do you have any suggestions for them?
Absolutely. Really focus on immersing the students with hands-on experience, right? Really bring things to really take apart in the class and understand what it is that they're looking at, what it is that they're touching, what function does it serve, and then relay that back to the education piece, right? The textbook elements, right? Because now there's a gap between what am I learning from a book and how does that apply to the real world? So we really need to bridge that gap, and how much we can make that more concrete in the students' mind and eyes would really help. First, get them interested in it, and sparking that creativity and that urge to want to learn more and delve deeper into it.
I can't thank you enough for helping our audience on several different fronts today. And David, so thank you for coming in. We've learned a lot about CAES, and hopefully if the audience wants to know more, they'll Google you and take a look at that wonderful website that explains a lot of this. But I want to thank you very much for sharing some of your insights and where the future of your industry is going.
Thanks for having me, George.
All right. Thank you, and goodbye, everybody.
For more information about the innovations and ideas changing tomorrow's world, tune into Tomorrow's World Today, now streaming on Science and Discovery, or visit tomorrowsworldtoday.com. For more information about the innovations and ideas changing tomorrow's world, tune into Tomorrow's World Today, now streaming on Science and Discovery, or visit tomorrowsworldtoday.com.